Hi, doctors. My name is Dr. Kirk Gair, and I'm excited to share with you this new laser that Erchonia has just come out with called the GVL. It's the first and only green and violet laser in the world. And we just got FDA clearance for this in September of 2022. And I've been using it in my office for a while now, and I was one of the principal investigators in the clinical trials to get this device an FDA clearance. And I've been using lasers since 2004, and I love the results that I've gotten since then. But this one is on a whole other level. So let's jump in and share with you what some of those results are. Now, before I get into that, I'd like to share with you how I got into lasers. And that was back in 2004. I went to a Dr. Murphy seminar. And Dr. Murphy, if you haven't heard him speak, you've got to get out and check him out. He was always been so far ahead of his time. He talked about back then that he had been using lasers. Specifically, he'd been using the Erchonia lasers, the low-level lasers here on his brain, because he said that it was important to use them there to keep your brain sharp so you can prevent yourself from succumbing to neurodegeneration like the rest of the population. And he told us that if you never used one in your practice, you should at the very least get one for yourself and for your family. And while we were in this seminar in 2004, he talked about how he had been using lasers since the 1980s, and the Russians had been using them since the 60s and 70s. And the reason why he decided to use Erchonia lasers was because of the volume of research that they did, and the research that was high quality, level 1 randomized controlled, placebo controlled studies. So that's why he jumped in and started using the Erchonia lasers. I started using them, and it changed my practice to where I was able to treat a lot more conditions. As a result of some of the things I did with chronic patients who have Hashimoto's. I got featured in The Thyroid Secret by Dr. Isabella Wentz, for those of you who are into functional medicine. She also talked about the things I did to use the laser to support patients, not to treat their autoimmunity, but to support their conditions, to improve their overall quality of life. She talked about that in her book, Hashimoto's Protocol. I also work with a lot of athletes, and I've used these devices, these Erchonia devices, to help athletes like Zach Shinnick here from USC. Helped him win a world title for the Pan Am Junior Games when he and his teammates set a world record in the 4x400 meters. I also helped him when he was at USC and they won a national title there and set a collegiate record as well. And I've also worked with people like Justin Deedit, who's the one of the captains for USC football this year. So that's a background on how lasers have changed my practice. And Erchonia invited me to be one of the principal investigators on this device. And this is what we did. It was for this green and violet combination laser that I have right here. And this was for chronic neck and shoulder pain. We'll get into the details on this a little bit more, but I want to start with some of the results that we saw during our clinical trials. We were comparing our results to previous studies with the red and violet combination and with red only. And what we saw is that each time that you add in another true laser wavelength, not an LED, sometimes people will cut corners and do one that's a laser and one that's an LED. We're using two true collimated coherent lasers that each time we upped it, that we got better results. So for example, when we did the green and violet, the average duration of pain in the patients that we saw in the clinical trials between my office, Dr. Comey's office, and Dr. Robert Silverman's office was 89 months of pain. After a single 13-minute session, doing half of that time on one side, half on the other time, we saw an average percentage pain relief of 52% immediately after that treatment. That is literally, we would measure it 1 minute later, within 1 to 5 minutes later. Then we had patients do follow-ups at 24 hours and 48 hours. And what we saw also was that their pain improved an additional 65% improvement in their pain from the start of this single session to even 2 days later. And the improvement in range of motion was 32% on average in these trials. And you can see with red only, it was 14%, red and violet was 29%, green and violet was 32%. Look at that pain drop, 43 with red only, 50% with red and violet, and 65% with green and violet. So there's really something big there with these results we were getting. And it actually was such a big result that it concerned me so much, because I thought, hey, is there something that I'm either doing wrong in the study, or that patients are, is there some type of a placebo effect going on here? Because these were wild at how big these drops were. And again, I was an experienced laser practitioner for a long time, but this is on an even bigger level, to where I even contacted Travis Salmons, who was running the clinical trials for us. I said, hey, Travis, I'm concerned that my results may be out of what the norm is in the other two locations. And he told me, don't worry about it, man. They're getting the same kind of result. And these are also long-term laser practitioners as well, but there's something in that combination of the violet and the green laser that takes these results to a whole other level, and that's what I'm going to share with you today. I do want to let you know about a couple of these patients that I had in the clinical trial that followed up with me with these long-term results. So one of the subjects, she was a female who was a college volleyball player and now a volleyball coach. For 6 years, she had chronic pain in her shoulder that affected her ability to play in college and affected her ability to coach. She'd had multiple sessions of PT, cortisone injections, etc. We did that one 13-minute session, and she had full range of motion at the end of it. And it's now been many months since we did the clinical trials, and she still has full range of motion, and she's still pain-free. Another patient who was in the clinical trials, he had played Division I college football back in the 80s, suffered from chronic shoulder pain. He could only bring it up to about 110 degrees in abduction, and he had severe pain, like a 7 to 8 pain just every day with it. Did the one 13-minute session. I was not expecting this reaction, but at the end of 13 minutes, and this is doing no soft tissue treatment, no adjustments, nothing, just the laser while we're doing some passive range of motion. He went up to 170 degrees of pain, range of motion, and his pain was down to about barely there too. He has maintained that range of motion, and he's also kept his pain low. And that's been many, many months since we've done the clinical trials. So these are some of the cool things that we saw. So let's get into how does this actually happen, because when you're looking at lasers, you got to think about, well, which wavelength or device is the best, and each wavelength affects the electron transport chain in the mitochondria, these protein complexes, differently, and it produces what are called wavelength specific unique photochemical effects that you can only get with a particular wavelength. And each of these wavelengths has a specific photon energy, which is called an electron volt. And certain electron volts, certain minimum thresholds are required to trigger specific reactions at different processes in the electron transport chain. So just to let you know, what I'm going to talk about is based on research. And this is a great book for you to check out if you're into laser therapy. Laser Phototherapy by Turner and Hode. There's over 135 pages of research references, hundreds of studies that are on there. The bulk of the studies cited are below 500 milliwatts, which is class 2 or class 3, because that's what most of the research is on. So always, whenever you're learning about lasers, fact check who's ever talking about it, including me. But do it in the legitimate way, not the Facebook fact checker way. Go in here and read these studies, go into PubMed and read the studies, and look for the quality studies, the ones that are level 1 randomized placebo-controlled studies, because there's a lot of unsupported opinion out there that is stated as if it were fact. So you want to look to see what is a specific wavelength and specific power for the FDA clearances. Do these devices just claim equivalency to another device that has totally different powers and wavelengths? Because the FDA can approve something because they consider, oh, laser is the same stuff, even if you have a different wavelength and different parameters on there. They're not looking to see, does it get the same result? Just can we clear it as being safe? You also want to check to see if there are level 1 RCT studies on there to support the claims. And for any manufacturer, check their references on their sites, because what you'll find, many will list references to studies on completely different product parameters that they say don't work in their marketing, yet they'll use them as a reference to support their devices that are totally different. We see this a lot to where other manufacturers will come out and say that Erchonia lasers don't work, they're too low power, etc. Yet then on their sites, they're citing all of our research and trying to say it is supporting their device. So just beware of those things. I also encourage you to take a look at this study, low-level laser therapy in Russia. The USSR was far ahead of us when it came to laser research. And this is a great paper to read. A few of the key points they found is that too much power dose can lead to a decreased or opposite effect, especially long-term effects. Pulsing lasers more effective than continuous wave. And a key thing here is that combining lasers and LEDs will lead to a diminished effect from the laser due to scattering inhibition triggered by the non-coherent light. So the reason I mention this is because there's a lot of devices out there, like I said earlier, that will try to go on the cheap and combine a true laser with LEDs and say, hey, this is just as good as, say, like the GVL that has 2 actual true coherent lasers. Well, going clear back to the Russians in the 60s, they already showed that's not the case, because the LED non-coherent light will create a scatter effect with the true laser, and you'll get a diminished result on there. So it's something to think about. So let's get back to now, how did this GVL create those results that you saw in the study chart there and in the patients that I talked about? And since I've added it in, I'm using it on all of my patients. I actually use a combination of green, violet, and red lasers on almost every patient, and you'll see why in just a little bit. What you have to think about is when we get a laser on a patient. So say when I get this laser on me here and I've got this green and violet laser, what's happening while it's there? Well, these are non-thermal lasers, so patients don't feel any heat. But what they're getting is they're getting this photon energy being absorbed by the mitochondria. The mitochondria are responsible for 90% of the ATP our body needs to function and has a pivotal role in cell life and cell death. And mitochondrial dysfunction is common in autoimmune diseases, aging, neurodegeneration, long COVID, and many more ailments. Now, what's important is that in the past, we thought that, oh, you had to put the laser directly on a site and it only has an impact here. But we see is that there's this abscopal or global effect that occurs, especially with the visible lasers. For example, as I have this laser here on my neck or any part of the body, there's free-floating mitochondria in the bloodstream that are going to absorb the photon energy and disperse it throughout the body. This allows photon energy to affect even sites far away from the application site. And additionally, different wavelengths of laser light can trigger biophotonic emissions from cells. And we'll get into that a little bit more. These will travel through the microtubules, through basically the cytoskeleton of the cells and of the neural networks, and even the myelin sheaths. They'll act like a fiber optic laser network. And I'll show you the studies on that. Now, for a long time, people have been talking about depth of penetration as being the most important factor. Well, there's been some misconceptions with how this works. And this research by Gerald Pollack talks about, you should take a look at his book called The Fourth Phase of Water. And he talks about how the body, in his opinion, in his research opinion, can be up to as high as 99% water. We know that certain things can be between 60% or higher on there, but he's estimating even higher, being like 90%, 99%. And so when we look at this, different wavelengths can propagate through water differently than through just solid tissue. So much of this talk about depth of penetration is looking at thermal impacts of infrared wavelengths. And in these studies, they use dead lab tissue models that it doesn't account for having blood cells, immune cells, neural networks, etc., and ignores other reactions that occur with visible lasers. So when we look at living tissue that has a high water content, you can see that violet and green light actually propagate, as you see in this diagram to the left there. They propagate further through a water medium than red or infrared do because they get more absorbed and there is some more of a thermal impact, particularly with infrared on there. Whereas when you go down to the violet and the green and the blue, they go a lot deeper into water and they propagate further. So additionally, when we use photochemical stimulating visible laser wavelengths, you have impacts on these free-floating mitochondria that I mentioned in the bloodstream. You impact the immune cells, cytokines, etc., and you trigger enzymatic cascades and cell signaling effects that, again, are abscopal or global. I encourage you to look that up. Finally, I encourage you to go into PubMed and research biophotons, and you will see that visible lasers can trigger the release of coherent biophotons that are laser-like, and that these can propagate through the body by these microtubules and myelin sheaths like a fiber optic network. Now, there are other independent studies, too, that talk about how the effects of laser can't be entirely explained by penetration of photons through the scalp and skull itself, especially when you're doing stuff on the brain. Here in this Harvard research, they talked about in mouse models of Parkinson's and Alzheimer's that even lasering the leg with the head totally shielded was able to trigger changes in brain function. It's another example of the abscopal effects of lasers that you don't hear about very often. And if you go into PubMed, you'll see, different studies like this, talking about these atomic water channels controlling remarkable properties of a single brain microtubule. That you have these computational connectionism with neurons, that there's a cytoskeletal automata subserving neural networks and all these neural networks here, and how individual photons can actually trigger changes in protein conformation here. So we look at this when we're talking about this with lasers. Here's the key concept. As I get a laser on the body here, I'm actually going to trigger some other biophotons to be released. Now, when we use an actual true laser, not an LED, the true laser will stimulate these coherent biophotons, because you can trigger these polarized reactions in the cell membrane, and their coherent signal can propagate through these microtubules in a manner that an LED does not do because of its lack of coherence. LED will actually get filtered out as background noise, but a coherent signal will be able to propagate through these neural networks. It's kind of like the fiber optic network that's bringing Netflix into your house when you're streaming. And these biophotons contain packets of what they call quantum information. They refer to them now as qubits that are theorized to make the brain function like a quantum holographic computer. So it sounds like some crazy out there sci-fi stuff, but that's the direction that the research is going. And when we look at this importance of coherence, we see that that cells actually speak in a laser-like coherent fashion. And that's according to James Oschman, PhD. And when we look at Dr. Fritz Albert Popp, he was a German pioneer in the field of biophotons. He talked about that all living things emit light, and a healthy person emits more coherent light than an unhealthy person. And cancer is a loss of coherent light. So I encourage you to look up their research as well, because we don't have time to really dive into that. So laser light is coherent, and it's considered the language of cells. LED light is non-coherent, and in head-to-head studies does not have an equal impact for most conditions. So let's say you're trying to say, well, I'm just going to go out and get a cheap device that's a green LED and a violet LED, and I think it's going to do the same thing. These are randomized placebo-controlled studies that Erchonia did versus LED devices. This was for chronic low back pain. You see the dotted line is LED. You see you did have an impact, but as soon as the treatment was stopped with the LED, the pain returned. Versus with the true laser, it kept getting better. So we're seeing long-term results, not just temporary pain relief. This is why Erchonia was able to get a chronic pain relief clearance here for low back pain. Let's talk about if we're trying to use LEDs versus lasers on the brain. This was the autism study that Erchonia has submitted to the FDA for review and potential clearance. You see the dashed line at the top. That's the changes with an LED device of identical parameters. No changes in their function, but with the laser, there's a big change in their function overall. You have one of the authors on the study that tried to claim that LEDs are equal to lasers actually admitted to me in this online conversation we had when he was trying to pump up how great he thought Erchonia's research was on lasers and autism, and he was trying to say it was good for LEDs. I pointed out to him, hey man, LED showed no improvement on there. He came back at me and said, well, in my study with Michael Hamblin, it showed that LEDs were the same. And I quoted back to him that in his own studies, there were only 3 studies that were head-to-head. And so at that point, he had to admit that, no, you're right, there's more research on lasers right now. And he said, but I think that it's my feeling that it's going to surpass them in the future. So he's basing his things on opinions and feelings. We're basing ours on research. This is for chronic neck and shoulder pain of true lasers versus an LED. And again, you see there's less of an impact with an LED. And for fat loss as well too, you're saying that laser can cause a 4.6-inch drop in circumference versus the LED was only 0.7 of an inch. So you're looking at 6 times better results with laser versus LED. So as we're talking about this, we are being laser specific, because if you try to do this with an LED in the randomized placebo-controlled double-blinded or quadruple-blinded studies, LEDs were shown to be either 0% as effective or up to 20% as effective. So if you try to go on the cheap and save money and get an LED, you're going to sacrifice 80% to 100% of the effectiveness in a single session or series of sessions. So something to understand. Now we're looking at these devices that are green, violet, red in the visible spectrum. There's a big difference between that and infrared. I'm not saying this to knock infrared, it's just they work differently. When we look at the visible spectrum, we have a higher energy per photon. This laser here is the most energetic laser in the world. That doesn't mean it has the highest wattage. It means that the inherent energy in a photon is higher than any of the lasers. We look at the violet wavelength, you have 3.1 electron volts per individual photon. Green is 2.4, red is 1.9 electron volts per photon. And infrared is down at 1.5, and that is significant for this reason. You need a minimum photon energy of 1.7 electron volts to cause electrons to jump to higher orbits. This is where you're going to see a lot of magic happens in the body. You can't make up for a lower electron volt, like how the infrared's down at 1.5. You can't make up for it to trigger the reactions I'm going to show you in the electron transport chain by increasing the wattage. It just doesn't work that way because the electron volt stays fixed, and we're talking about wavelength-specific reactions. So why is this important? Approximately 1.7 electron volts, which has a maximum wavelength of 730 nanometers, is required to create photochemical reactions. And this is what a photochemical reaction looks like. So let's say when I've got this green-violet laser here, and I apply it here, say on my head or on my body, my neck, or my arm, or anywhere, one of the things that's going to happen is that violet laser, which has the highest electron voltage at 3.1, it's going to cause electrons to jump to a higher orbit. And then as they do this, when they fall back down, they're actually going to release biophotons on their own that are coherent. And it'll release a green one, and they could trigger and release a red one and an infrared and so on. With green, It can cause it to kick up and then release a red biophoton. With red, it can cause it to kick up and then release infrared biophotons. So we see that there's a specific shift that can happen that when you have an infrared wavelength, it doesn't have the energy to impact in this same method on there. And I know, don't get offended if you have an infrared device and you love it. I totally understand that. We're just talking about some different uses for different lasers, how you can add to your arsenal so you can impact patients in additional ways. So when we look at this with the visible wavelength lasers, we're talking more about photochemistry. I'm getting some really cool studies on exactly how we're impacting people. So Boston University talked about then when molecules absorb these visible or ultraviolet light, they become electronically excited. And when this happens, you can result in breaking, reforming, and rearranging chemical bonds, as well as electron and energy transfer between various parts of the chemical system. So you can't achieve this with infrared light because the electron volts are too low. Those lasers work differently. And these are some more research studies to back up what I'm saying here. So when we look at what Tuner and Hode said, they said that visible and infrared affect biostimulation in different ways. Visible light elicits photochemical changes, while infrared can only produce physical changes. Stanford University said although visible light can produce photochemistry, infrared only produces molecular rotations and vibrations, so it's different. And here this talked about using a red 635 laser can increase nitric oxide production, whereas infrared and far infrared can't because they have too low of an electron volt. That photochemistry is not enough to cause these jumps. So basically, when we're looking at the world of lasers, there's also a difference in the way these visible infrared lasers work, is that visible lasers are working in more of a quantum manner by impacting smaller energetic components and impacting cell communication networks, electron transport, and photochemical reactions. Infrared lasers are more in a Newtonian model. They work on large tissues, having photothermal impacts, rotational and vibrational impacts. So if you're currently using infrared lasers or class 4 lasers or LEDs, adding visible wavelengths to your arsenal can have you add an additional impact for your patients that you just don't get with your other lasers. So let's look at this one here from Stanford University to show you an example. So like when I take this GVL and I place it on, say I'm doing some neck work on here and I've got it on the neck and I'm doing some movement here, we talk about that just one photon can activate one enzyme molecule, which in turn can process many thousands of substrate molecules. And if the effect of that one photon can be amplified biologically, then one does not need a lot of photons. That means a lot of dose, a lot of wattage to produce an effect. One just needs to find the proper wavelength of light to stimulate the proper enzyme, which in turn will stimulate the beneficial therapeutic effect. And this is where we see some of the magic happening with the GVL in the electron transport chain. So if you go back to when we were in college and we're learning about the complex 1, 2, 3, and 4. These are important things for the overall health of the body, the mitochondrial electron transport chain. So key concept here, complex 1 is considered to be a rate-limiting reaction. And if there's a dysfunction there, it will affect all downstream complexes. You can only impact complex 1 and complex 2 with a violet wavelength, as it is the only one with enough electron voltage or photonic energy to trigger the necessary electron jumps. With complex 3, the green wavelength is required to stimulate these electron jumps in there to get it to move on to complex 4. So if you have a breakdown at complex 1, it affects everything downstream. Complex 2 affects everything downstream. 3 affects everything downstream. So you have these areas that can break down that only violet can impact or only green can impact on here. And then the last phase on here of complex 4 is where the red lasers have their impact on it. So the key thing here is that it plays a role in the production. And if one or more of these complexes are inhibited, then ATP will be limited. And so if you have limited ATP, how does that affect the body? So what diseases are affected by the mitochondria? Well, what we see a lot as chiropractors is skeletal, muscle, and movement disorders. You may see some neurological disorders or have autistic patients in your office. We'll also see patients coming in with neurodegenerative diseases, but we see things with your patients are in your office, they have cardiac diseases, they have cancers, mitochondrial diseases, metabolic ones, renal dystrophies, they're aging, they have pulmonary disorders, vascular disorders. Any of these are affected by the mitochondria. So when you have a patient in your office and say they're using a laser for low back pain or neck pain or something, they may see some improvements in these other areas as that abscopal or global effect of the laser helps this patient. Now, what are some common examples that can inhibit the electron transport chain and can impair mitochondrial function and lead to some of those dysfunctions that we saw on the previous slide? Well, a simple one are just common pain relievers. NSAIDs, aspirin, indomethacin, diclofenac, piroxicam, and ibuprofen. These ones can impact and inhibit the electron transport chain. So you think about this. How many of your patients are on these drugs, that are impacting mitochondrial complex 1, and that affects the whole downstream production? So key thing is, again, that's a rate limiting reaction, and it will affect all downstream complexes. You can only impact complex 1 and complex 2 with a violet wavelength. It's the only one that has enough energy to do this. Now, this is showing acetaminophen, that acetaminophen can affect the mitochondrial respiratory chain at complex 1 and complex 4. So if you want to use a laser to affect patients who've been taking acetaminophen, you're going to need a violet wavelength for complex 1 and a red for complex 4. If you only have one of them, you're going to miss out. If you just have red, which I got great results when I first started with red for the first 4 years in practice, but when I added violet, I started getting even better results. And I saw why, because we're now impacting complex 1 and complex 2. If you add in green, you can impact complex 3 as well and get a more complete result. Now, if you follow along with research, you'll see that there's this class action lawsuit of the link between Tylenol and autism. And a key concept is, as I showed you already, Erchonia has already showed the effectiveness of low-level visible red laser on kids with autism. But let's look at this. Let's look at, if you add in green and violet, you can impact it even more, because this study showed that in children with autism, they had 60% had issues with complex 1, 2, and 4, and you had 40% that had issues with complex 3 and 4. So that means that if you wanted to make sure that you were able to help all of these different kids, you would need to have a green, a violet, and a red laser available. This is why in my practice now I'm using all 3 of the wavelengths regularly on almost all of my patients, with a few exceptions on there. Because how do you know which one of their complexes is off? Can you test for that in your office? I'm not aware of any way to particularly test for that. So I think it's much easier, and there's not any risk of side effects in most cases, to apply these 3 different wavelengths on people to get the whole impact on the whole electron transport chain. And that's the key point. If you're missing any one of those wavelengths, you may be missing the one that your patient needs to make a breakthrough. And this can lead to a vicious circle of mitochondrial dysfunction. And as the mitochondria get dysfunctional, when they replicate with these mutations and with genetic loss. And so you get a worsening picture over time. This actually accelerates their aging process, accelerates the dysfunctional process as well too. When we look at it from a pharmaceutical perspective, they're talking about how they don't really have any therapeutic approaches for mitochondrial disorders. They've lagged behind. Their treatment options are limited mainly to symptom-based therapies. But here, as I've shown you already, we can actually help these mitochondrial disorders. So if you've got a patient with autoimmunity, and we apply these, like let's say if I'm doing functional medicine, I'm trying to provide support for my Hashimoto's patient or my MS patient, I can support their mitochondria, because almost all of these autoimmune conditions, you see some issues with mitochondrial function. There's some studies showing that long COVID can impact mitochondrial function. So we get these 3 wavelengths on there, boom, we can have some support for these patients to help improve them. So the key concept here is that to be a laser Jedi master and impact all the facets of the electron transport chain to fully support mitochondrial health, you will need 3 true collimated laser wavelengths: violet for complex 1 and 2, green for complex 3, and red for complex 4. So let's get more into that. So what I would recommend doctors to consider doing is to get a base station. The base station, you get 3 lasers for a greatly reduced price. Mine has a GVL, which is green and violet, an EVRL, which is violet and red, and an Accelerate, which is dual red. Now, we also rent out the lasers to our patients for additional revenue streams. Like right now, I'm closed for Christmas for the last couple of weeks, and I'm making $1,500 off of 2 of my lasers being rented out during this time. If you want to learn more about that, you can join my Facebook group at Dr. Gair's Laser Therapy Treatment and Marketing Secrets for more information on there. And this just shows you, as I introduced this program, I had patients that were really excited to jump on there right off the bat. We usually have them reserved out in advance. This is one of our doctors. You can read what James Schwartz had to say about doing rentals in his office, that he actually, his biggest problem was he had to buy more lasers to meet the demand on there. So it gives you a nice little extra revenue stream, so you can have rental lasers paying for your new lasers. So it's not as much of a financial commitment. You can be making money both in the office and also passively with them at home. So we look at which lasers to use. What are the advantages of multiple wavelengths? So I already showed you that you need all three to hit all aspects of the electron transport chain. But what about if you're just doing good old-fashioned musculoskeletal types of things? Well, we know that the red laser worked great for that, for chronic neck and shoulder pain. We got an FDA clearance for it, showing that it was superior to an LED device. When Dr. Silverman did these clinical trials on red and violet, that was even better. And then when we did green and violet, it's even better. So if you want the best results on chronic musculoskeletal pain, you do green and violet. When you have that higher electron volt of photonic energy, it's better at breaking apart scar tissue. We see a faster improvement in range of motion and a faster drop in pain. Now, what about if you have patients with osteoarthritis and you really want to impact them again for the long term? So you have some options of trying to do things that are just for temporary pain relief. But if you're trying to actually stimulate some changes in these chondrocytes, you're going to need a violet and a green laser, because these studies show that there's mitochondrial dysfunction in patients with osteoarthritis in their chondrocytes. And they have problems at complex 1, 2, and 3. So you use the violet to help them with complex 1 and 2, and you use the green for complex 3, which you can't do that with just a red or an infrared. Just won't happen hitting those two pathways. Let's say if you're like Dr. Trevor Berry and you do a lot of neuro cases, this will show you different conditions that have different impacts at different parts of the electron transport chain. So when we see with Alzheimer's disease, the AD over there, there's problems at complex 1, 3, and 4. Parkinson's is complex 1 and 4. Huntington's disease is at 2, 3, and 4. ALS is at 1, 2, 3, and 4. So when you use different wavelengths, you can affect different conditions, because like if you use violet and you're impacting complex 1, this impacts tau and alpha-synuclein. If you're using it at complex 2, it impacts MHTT involved in Huntington. Green impacts complex 3, which impacts MSOD1, and red impacts complex 4, which is for amyloid beta plaques. So again, you can see if you're missing any one wavelength, you're going to miss a critical step there in the electron transport chain, and you might not be giving a full impact to your patient of what they may need. Now, how about for aging? So we see that aging is involved with complex 1, 2, and 4. So this is one where you need a violet and a red to help these patients to slow down the aging process. Same thing with obesity. We see issues with complex 1 and 4. And again, I'm going through this research fairly quickly because we only have a limited time. So if you want more of this information, be sure to join my Facebook page, and we can continue the conversation there. Also, make sure to get out to an Erchonia seminar as soon as you can this year, so you can learn in more detail on this and ask questions live. Now, what about when we see these ATP levels lead to hypersensitivity and chronic widespread pain? So think about your office. How often do you have patients in there, or your fibromyalgia patient, your chronic fatigue patient has just chronic widespread pain, and we're seeing just a general dysfunction in their mitochondria dysfunction. I like to get all three of the wavelengths on these patients so that we can impact all of the different complexes in the electron transport chain to try to improve their overall function. Now, this was a study done on Erchonia lasers at the University of Illinois at Chicago Medical Center on patients with renal fibrosis. And so here they found that each individual wavelength had different impacts, that the 635 really helped with mitochondrial activity and proliferative activity, production of interleukin-10. 405 violet helped with the reduction of apoptotic cells on fibrous tissues, also improved breakdown of scar tissue due to the high electron volts. And 532 green helped with reduction of transforming growth factor beta and had the biggest stimulation on stem cells. So again, different wavelengths impacting you in different ways. Now, this is one of my favorite studies talking about how visible lasers of violet, green, and red can actually impact the disc and the annulus to create repair in the annulus fibrosis. And this is important because there's a lot of misinformation out there saying that, oh, a visible laser can only penetrate to the skin, so it's only got dermal impacts and it can't impact the disc at all. Well, there's tons of this research out there. It talks about how you can get this propagation of the extracellular matrix modifying enzymes to penetrate to a deeper level and to actually repair these tissues on here because of the enzymatic cascades and electron transport reactions that are triggered. This produces that global or abscopal effect. And I was involved with this study that we put out on the effects of low-level red laser compared to NSAIDs, opioids, and other light sources. And this is Dr. Trevor Berry, also an Erchonia presenter. It is double-blind, placebo-controlled trial evaluating the efficacy of red 635 nanometer low-level laser for the treatment of low back pain. We already went over this compared to LEDs, that you see these long-term effects. And that's a big difference here too. When we're using these true Erchonia lasers, at their level, we're seeing long-term benefits, even at deep tissues on here as well too. And here is another FDA clearance for post-operative pain. So this is another one where I do a lot of rentals. If I have a patient going in for surgery, I will do a rental on them for a couple of weeks beforehand, and then for a couple of weeks to a month after they come out, so they can do the laser on themselves at home. What we see is that these patients tend to be months ahead in their therapy, and they tend to have a better recovery on there. So let's look at what are some of the differences in these green wavelengths according to research. So with the green wavelength, we're seeing that, let's say if you got a patient who's had a fracture, we're finding that the green is more effective at facilitating bone repair than red or even than violet. And here they really found for doing blue and green lasers that this was the best for osteoblast differentiation compared to visible red or even infrared on there. So what I like to do with a patient like this is I would do if they have a fracture, I would do a home rental for them and have them rent the GVL and do laser treatment on a daily basis to get the best results. Now you can still do it in your office. We've done that for years, but we really are moving into a model where we're doing a lot of home rentals with the patients, and they really enjoy it and get really good benefits with it. And since these are class 2 lasers, we can do that and know that they're safe for the patients to use at home. When we look at the function of mitochondrial transmembrane potential, the green laser really helps with that. And here's a big one. People always ask about peripheral neuropathy and the peripheral nervous system. This compared visible red lasers and green lasers, and they found that visible red and green did have an impact. Infrared did not have an impact for peripheral neuropathy, and the green laser was shown to be the most effective here, and also on this one as well too, that for injured nerves, green is shown to be more effective than even red laser. So in my office, if I have a patient who's got a fracture, I'm going to try to have them do the GVL rental or come into the office and do the GVL. If we got an injured nerve, I'm going to make sure I'm using the GVL because I've got the green wavelength on there as well too. Now, what about the violet wavelength? What do we get with that? We see that violet, when comparing to green, red, and infrared, that it was better at impacting nitric oxide levels. It was even better also at respiration, the differential responses in myoblasts and myotubules. You had a better result than other wavelengths. Same thing here. We got more reactive oxygen species. Now, you don't want to produce too much. You want to get the right amount on here, and the violet laser was really good at producing that right level that you want there. And then lastly, antimicrobial effects. This is really important these days with, people worried about COVID, different infections, the gut microbiome being affected. You can get these violet lasers on. And again, because you're getting the laser, not just a direct penetration through the tissue, but you're also stimulating immune cells, you're stimulating mitochondrial reactions. These are going throughout the body, and they can have an impact at deeper levels. And so you can actually see some improvements with these patients for their overall immune function too. Now, the question people always ask then, we've already talked about differences with LEDs. You should clearly be able to see that. I think LEDs are great for a patient to use at home if you're using them in the office. That's like I had a 6-cylinder Ford Mustang, looked like a great sports car, but if I tried to go race in NASCAR with it, I'm going to get my butt kicked on it. It's not even close to it. That's the difference of an LED versus a laser. It's fine for using those LEDs at home, but if you're trying to use it in the office, you're just not going to get as big of a wow factor as you are with a true laser. So how about high power? So when we look at power versus energy, here's so many people talking about this is the most powerful laser, most highest wattage that's out there. I've shown you this one is the most energetic. And so this has this impact in the electron transport chain. When we look at power versus energy, power is wattage, energy is electron volts. So the electron volts are only in fact impacted by what that wavelength is. No matter how much you ramp up the power, it has no impact. So what does power really do? Well, by adding power, and this is based on that big book by Tuner and Hode and research by Hamlin and everybody else, when you add more power, you add more photons per second. Increasing power can push more photons in the tissue in a shorter time. Now, here's the issue, though, that you have to be careful of, is when you have higher power, you can also push past the hormetic threshold. And when you do this, you can trigger a different or opposite effect than you do at a lower dose, or even at the same dose, but over a longer time. When you increase power too, you do have more potential for a thermal impact and for injury, especially infrared, since it's not visible to the eye, the blink reflex doesn't protect it. So it's what you have to look at here. Currently, all high-powered devices, with the exception of some of the super pulse lasers, they're currently only cleared for temporary relief of pain by increasing temperature and blood flow. And don't believe me, go on the websites, look at what their 510 clearance is. And again, no matter how high you put the power, it has zero impact on the electron volts. So you can't affect complex 1, complex 2, complex 3, etc., like we talked about earlier. So here's an example. Say we take the GVL here and we're looking at the violet wavelength. Photon energy is 3.06. If we're at 1 milliwatt, look at how many photons come out per second. There's 20.4 quadrillion photons per second at just 1 milliwatt. If we go up to 2 milliwatts, it doubles that to 40.7 quadrillion photons, but the photon energy is still the same. So it's just important for you to understand that. A few things that increasing power does not do. There's some sales myths out there. Again, don't take my word for it. Go get the book by Turner and Hode, read the research they cite in there. When you increase the power, it doesn't significantly increase the depth of penetration unless you do some super pulsing types of things, but it doesn't have a big impact on there. It's a common sales pitch. Depth of penetration affected into tissue affected by the wavelength. But as I showed you earlier, when we're in living tissue with a lot of water in there and immune cells and plasma, etc., now you've got the visible lasers that are going throughout the whole body, through these microtubules, through the circulatory system, etc. Key point here. Increasing the power does not allow you to get the same result as a low power in a shorter time, even if the dose is identical. That's a lot of just opinion stuff out there. I'm going to encourage you to fact check me on that and look at it. Read through Turner and Hode, read the Harvard research by Hamlin, and what I'm going to show you here in some other studies in just a moment. And when you increase it like this, it's similar to trying to push a medication in a higher dose in a shorter period of time, or an IV in a shorter dose versus, say, like a time-released capsule. It just works differently on there. That's just the way it is. Or trying to push it in a shorter time, it's like the difference between slow cooking ribs or microwaving ribs. When you push the same energy in a shorter period of time, you get a different reaction in the proteins and in the structures of tissue. So let's check out, though, what Harvard research says and what the World Association for Laser Therapy says, too. So this talks about a dose response. So whatever laser you have, it's important for you to understand this. You know, whether you're using Erchonia lasers or not using them, or you're using other lasers, I encourage you to look at the research and apply them to whatever device you have. Hamlin's research at the University of Harvard talked about how you get a sweet spot of you don't really want to surpass 10 joules per centimeter squared, or you start to get diminishing results until you ultimately get negative and inhibitory results. And at very high dosage, you can trigger DNA damage, increase reactive oxygen species, and decrease cell viability. And now here's the paradox, though. Many times when you pump up a dose really high, you can get bioinhibition, which can trigger a quick drop in pain. The problem there being is that you get this increase in temperature and circulation from high dose, but you can trigger these other long-term things that they talk about in this Harvard research, like DNA damage potential, increased reactive oxygen species beyond the therapeutic benefit, and a decrease in cell viability. So it's important for you to understand that. We look at the dosages recommended by the World Association for Laser Therapy. You see most of these are between 4 and 16 joules. So beware that some people are teaching others to dose several hundred to even several thousand joules. And that's not supported by most of the studies in Turner and Hode, nor by the Walt, nor by Harvard research. And this is research here by Harvard that shows that if you're using different dosages, that if you try to do the same dosage in a short time, you don't get the same effect as doing the same dose in a longer time. So when you go more power, you also have more of a chance for heat on here. This is why when we look at class 4 lasers, those ones, all of their clearances say they provide topical heating for the purpose of elevating tissue temperature for temporary relief of muscle and joint pain and stiffness. So this is important too when we look at this other research here, showing that it's accepted that laser therapy conforms with the Orange-Schultz law, that a therapeutic window of laser doses may exist between energy densities of 0.5 joules per centimeter and 4 joules per centimeter square. Dosage above these may result in bioinhibition. Harvard research said that fluences of red or near infrared as low as 3 to 5 joules will be beneficial in vivo, but a large dose of 50 or 100 joules will lose the beneficial effect and may even become detrimental. Turner and Hode again said biostimulation has been reported in the literature with doses from as low as 0.0001 joules per centimeter to 10 joules per centimeter squared. So it's important for you to understand that, because there's just a lot of misinformation that's out here, because this is showing that even doses going into 10 and 16 joules can result in a decrease in cell viability and mitochondrial activity, with an increase in percentage of cytotoxicity and DNA damage. This is particularly true here too when we look at this study on 405 nanometer violet light, which is what we have here in this GVL in patients with COVID. And in this, they specifically said that you didn't want to exceed the power dosage because of the high electron voltage on here. Now, this is significant because I just want to issue a warning. There is a device coming out that's trying to use 300 milliwatts of power in the violet wavelength. And here you have where they're not wanting to exceed just a few milliwatts on here because of the high energy of that wavelength that could potentially create some problems. So I want you to do your due diligence and research things before you go and buy something or think that, hey, just because it has more power, it's better. When you combine that level of power with this high electron voltage, it could potentially overload patients and create a problem and go beyond your hermetic threshold as well too. Same thing here when we're looking at lasers and affecting cytokines, that if you do a lower level of it, you have a positive impact on cytokines. If you go too high, you can actually trigger inflammation. It's like the Goldilocks zone or the sweet spot kind of a zone here. So as we're coming to an end here on this, let's look at what are the different FDA clearances. And these are important for you to understand because they affect how you can market your device and how you can use it in your state, depending on what your scope of practice is. So let's take an example of this laser here. So we look at the 510 clearance. You can look this up, the Avant laser. This one is cleared specifically for topical heating for the purpose of elevating tissue temperature for a temporary relief of minor muscle pain. So this is what's called a ILY type of a clearance. And so if you're using a laser like this and you're using it on the head with high doses, it's important to understand that you'd actually be using that in a way that is not supported by FDA clearances. So if you were marketing your laser, saying that it can do this or that with brain stuff, you can actually run afoul of the FDA. And if someone gets injured, you could be in trouble with this because we're not supposed to apply these heating types of devices onto the brain. Additionally, if you look at their laser, it's non-collimated, their red laser. It means that it doesn't have this collimating device. So when we look at, say, this, let me show you with this red laser here. When you see this one that I have, you can see like the lasers here on my shirt, you can see it's a clear line no matter how far I bring it back. That's because it's collimated. That allows the laser still function as a laser from a distance. When you look at a device like that one and it's not collimated, it blows out and it looks like a high intensity light device because it's not collimated. So it loses some of its laser function like that. It becomes more like an LED at that point. So it's important for you to understand those things there. They also don't do research to get FDA clearances. They claim equivalency. If you look on their website, they'll actually link to some of the studies that Erchonia has put out there to try to say it does the same thing. So anyway, that's something to look at. There are they'll show also people using these high doses of up to a couple thousand joules on the head. If you go back and you see what I showed you from the World Association for Laser Therapy and what Harvard says, there could be some potential problems on there. So please, before you just follow what I tell you to do or anybody does, do your own research because you're the one who has to ultimately protect yourself. And if you're following things that people are doing that are running contrary to the research and contrary to what the FDA clearance is, you're putting yourself at risk. If a patient gets injured because you used a thermal device at a very high dosage on the brain and they have a negative impact, you're leaving yourself wide open to some problems. So let's look at another device, and this is not to knock this device. It's just to understand what is FDA cleared for. That I know doctors who have this device and like it. Here's the deal, though. It's only FDA cleared for elevating tissue temperature and increasing circulation for pain relief. So understand that because when you do your marketing, you want to stay in compliance because if you don't, you have something happen like happened to CureWave. They were putting out different ads saying their lasers could enhance nerve function, quicker wound healing, fights bacterial infection, all these different things. The problem is because they have this clearance, the ILY clearance, it's intended to provide topical heating to the treatment area. So the FDA told them, evidence collected during our inspection demonstrates that your firm is marketing these devices with intended uses of tissue regeneration, healing, and improved vascular and cellular integrity. So that's what you have to be aware of, is you also have to make sure that your marketing and your message matches what your device is FDA cleared for. So in contrast, when we look at the FDA clearances that we've gotten from Erchonia, these are non-heating, non-thermal modalities. These are based on level 1 placebo-controlled trials versus LED devices. Same thing here. This is the FDA clearance we got for the GVL, and you see it's under this pre-market review for neuromodulation and physical medicine devices. It's talking about it has a non-thermal impact, and Erchonia has the most FDA clearances out of any laser company that's out there. So when we look at this, it's cleared as a non-thermal, non-heating modality. We look at the non-heating modalities that are out there. Erchonia has 9 of the FDA indications for pain with these devices. All of the companies combined have a total of 6. So when you use Erchonia lasers, you have the most research behind them. You have the most FDA clearances. So they provide you a broader spectrum of how you can advertise your lasers, how you can talk to your patients about them, and stay in compliance with your board and stay in compliance with the FDA as well. So we look at these 20 different FDA clearances that are here from Erchonia, and you can see that on their website. A lot of information there. And doctors, I'm bringing this to a close right now, but I want to encourage you to continue the conversation. If you're still on Facebook, if you haven't left it, we have over 800 doctors as of today that are in this group. And this is a great place where you can ask questions. We can continue the conversation. We have other doctors who are saying, hey, I've got this patient with this. What have you tried? And everybody's helping each other out and trying to make everyone better. You're welcome to join it no matter what laser you have in here, so you can find out how doctors are doing things. If you're looking for tips about how to implement a laser rental program or a Zerona program or the GVL, especially since it's so new, you can hear the other stories that other doctors are talking about what benefits they're getting with the GVL. It's really exciting to do. So please join this. You can go into Facebook, just type in Dr. Gair's Laser Therapy Treatment and Marketing Secrets. Make sure you go to Erchonia.com, look at the upcoming seminars. Make sure you get out to a live seminar because our goal is to try to do the best we can to train you how to use these lasers. If you come out to see me, I do a lot of hands-on. My goal is to make sure that by Monday morning, you've got things that you can do they're in your arsenal to where you know how to apply a laser as a basic point and shoot type of protocol, or if we're doing some advanced type of rehab protocols or sports performance enhancement as well. So I want to thank you for your time, and hopefully we'll see you in a live seminar or in the group online.